All right, guys. So today we're gonna talk about uh, DLL injections. So basically, can you see my screen, right? Yeah. All right. So yeah, today we're gonna talk about a little bit on DLL injections. How do they work? How we can use them with exploit pack in conjunction with the utilities that we have. And so basically, you will learn today. You will learn two sides of it, two sides of it. So basically, on the first, on one hand, you will learn how a DLL injection works. If you don't know. Basically how it works. You will learn about that, the basic concepts, but you will also learn how to use them in a more advanced way. Also, how to use them in a real pen test or a red team exercise. How to get execution during runtime, during in a box, in an endpoint, and also how to use utilities from exploit pack and combine these yeah, how you can combine this to get your own code executed, shell codes, or anything that you needed. Maybe an exploit, maybe as a side channel, maybe as a post execution, post exploitation module, or yeah. So all right. So let's first let me choose first go to exploit pack. So for this, of course, you need to have you cannot do it with the free version. You need to have your license on. Um, so if you go to the utilities tab, you will see that you have a bunch of privilege escalation techniques that you can use. One of them is the .NET profiler. So, and you can also remember that if you go, of course, you might use it or may not, but if you go to the red team tab, that is basically kind of a C2 that you can use. So with here, you can use the reverse shell, the BBS payload, and the cross-scripting shell. So from here, you can create these type of agents, these payloads, and then you can run them directly on the endpoint and get control of something with the resources, with the access that you can get out of them, of course. And I think I already mentioned it, but in the next release, we are going to include a few more agents based on .NET, in PowerShell, some others. So basically, also stagers with shellcodes and so more. So you will have a few more agent types to play with. So, but how can you get after you get some type of vector of attack, and then you deploy your exploit, you conducted that attack, and then you have an agent running. How to get execution after the machine is completely when you have a channel and you have already connected to it. Well, you can use a DLL attack, DLL injection type of attack. This one I'm going to show you here, through the .NET profiler is well, there are a bunch more of them, but this one example is by using the .NET profiler. You can get execution in the machine, and then every time the machine reboots, you will keep the access. So the access will go. So basically, the access will go through the .NET profiler that you can set up with these three environment variables. What is the .NET profiler? Basically, the .NET profiler is, as the name says, is a profiler from .NET that you can use to make a profile of your .NET app. You can look a little bit deeper in the MSDN documentation online, but I don't want to go deep into that right now, because I would like to focus more on the on not on the vector of attack on this part, but more on the DLL injection itself. So, but it doesn't matter. You can use this, and then what is important is that you're gonna get a DLL injected into every process that that uses .NET. So that's what you need to know. So what's going to happen is that every time you execute an application and that uses .NET, then it will get your DLL injected. So if we go, here, so this is just, oh, I think actually that I have there on Exploit Pack. Yeah, I have this. This is an example of a DLL that you can inject. This is basically I choose like a minimalistic example of a DLL that is basically injecting on the, yeah, you have four different stages. So when the process attach, when the thread attach, when the thread detach, or the process detach. So basically these are the first two, and then this the second two, and this the first two. So when is a process attached or a thread is attached, then the output that would be the thread is attached to the process attached, that you can inject or you can take control of those four. In this case, is we are only injecting ourselves into the process attached. And then what's going to happen is that every time the process is attached, so basically this DLL is attached to a process, we're going to run winexec, and then CMD is going to be replaced by this, and then we're going to run winexec. There is a system function that's going to choose get system from it, and then execute the command. You can choose give the argument show normal, or you can use hide or something if you don't want to hide the process itself, and then exit process. So basically we'll exit the whole process. Let me sip my coffee. So this is the more basic thing you can do with a DLL. So basically, then if you set this up, and he's using Win API instead of API entry, but it doesn't matter for this example. So you have to copy this, and this what it's gonna do. If you run it in the console, it's gonna do rec add. So basically running rec.exe, and then argument add, and then set these registry values. So for HQ, so it is HQ current user, software classes, CLSID. This is just an example CLSID. So basically, this is FFFF. It doesn't matter because then use it as a reference. Then we set improc server 32, and then we set the value for that to this path. You can use the path that you wanted, but see Windows task is a path that you can use. It's basically a stamp or something that you have full control of it. I mean, when I mean with the full control is read access. So well, you can change it if you want. Same for the key, but you can change it. But you can use this one. Doesn't matter. And then we set the core profiler in the environment as for the environment variables. You can set it directly on CMD itself. You can set it in different ways, but this is just setting it up from the console, and then setting up the core profiler with the FFS key, and then enabling it. So we set it to 1, and then the profiler path we set it again to test DLL. Yeah, so we have this key set to this path, and then we have the profiler set to the key that we previously set with this CLSID, and then the profiler tab. So this is what you have to do, like copy, then you go to your CMD, and then I think I already have it here, like that. I think guys, there is a typo. Just remember this. I think there is a typo here. If you open your exploit path and go to the non-profiler, there is a extra command here, so you have to remove it. So just like that. This is for adding it, and then of course the other one is you choose to want to remove it. If you choose want to remove it, then use the delete one. All right. So then, oh. do it like that. And then if you get the operation completed successfully, then it means that it's done. You can reboot your computer or refresh your environment variables, type set, and then you will see that you have these three environment variables set as we wanted to one. The .NET Core profiler is going to be set to FFFFF. That's the fixed key that we pre-selected, and then the test DLL. You can verify that if you go to the registry editor, and then you can go here like so. You will see that here's our key, the one that we just created, and if we go inside it, you will see that we have it here. All right, so that's enough of the .NET Profiler. So the only thing that you need to know about that is that every time any .NET application runs, you will get the DLL executed. It means, and because Windows use almost, let's say 70% of the apps that runs on modern Windows operating systems, they use .NET. So it means that you will get an auto run type of execution. So every time the machine boots and you have something running .NET, like the calculator or anything else that runs on Windows, you will get your DLL executed on top of it. And yeah, and you can also get a privilege escalation on top of that. But it doesn't matter the privilege escalation on this case. The only thing that we wanted is to get our DLL injected into a process every time the machine boots up. This technique is not detected by antivirus. Why? Simple reason, because this is a feature for .NET and it's not a malicious activity. It's actually, we are using a feature of .NET. We are using it for IT security, for pen testing, red teaming, but in any case, this is just a feature of .NET. So basically, it's not malicious. Well, it might be, but we are using it for a different, from a different perspective. But in any case, you can get to do that, and it's not gonna be flagged by your AB at any point. So good, right? Okay. So all right. So then what happened? Why? So let's start from the beginning. So why a process would like to use DLL? DLL stands for dynamic library. And then why do they use DLLs? So they can use wherever is on the system. They can have the libraries on different files. They can be more organized. They don't have to be fully statically compiled. They don't have to be a binary of 100 megabytes. They can be you can choose compile a binary that is small and then use different type of libraries. And how do they work? These libraries, they get during runtime, they get loaded into your binary, and then from that binary you define the offset of the library, and you can make the calls to the functions that you need based on the base offset that you have previously defined during runtime when you load it. And then then you will get to use the functions inside the library. So if you have functions, I don't know, for you make a library that will choose open paint, and then you make a function. You make a function that will open that paint program, and then you can import it into your library. You can import it into your binary from that library, and then you can use that function, right? Make sense? So let's can make a pain out of it because we were talking about pain. Let me just quickly check if we don't have anyone waiting. No, it's fine. So, all right, so let's say this is your binary, then you have different DLLs here. So it's gonna be bin, and these are DLLs. All right, like that. So, okay, so in your binary, you might have, how do we use paint? Okay, so you have this function, this function, this function, and then on the other one, you have these three different functions. And in your binary, you want to call this, let's put a name on it so it makes sense. So, so it's function A, and this guy has function set. And then from your binary, you want to use function A, but the function A is on this DLL. Then you can import this DLL into your binary, and then you can use function A. For that, you need to say, I want to use function A in your binary, right? I want to use DLL, this, right? The name that contains, I don't know, this fictional DLL. So that's basically what we use libraries. I mean, something you can do. I mean, you can have all these in the same binary, but as I mentioned, then your binary is gonna be huge. So that's why we don't do that. And then it's gonna be statically compiled. I mean, it's fine because then you don't have to depend on the DLLs that you have on your binary, but then yeah, then your binary is gonna be huge. It's not gonna be fine. You might be able to optimize it a little bit, but it's not the way. So that's why we have DLLs. So when you load this DLL, as I mentioned, the DLLs, it will be loaded in the binary. So during runtime, now let's go to runtime. So runtime means during execution. So when the binary is executed, what's gonna happen is that this binary, so let's say fictional.exe, and this is a.dll and b.dll. So when the user says, I want to run fictional.exe, then it will be loaded first into memory, loaded into memory. Then this is runtime, right? This is what I'm describing. Then after being loaded into memory, it's gonna to be executed, get execution, and 3 is gonna load DLLs. Yeah, I'm just describing some basic concepts, right, guys? But if we look at the forest, it's gonna be sort of like this, right? So you have a better understanding of the whole concept. So then when you load this DLL, this is where we want to inject ourselves. So the DLL injection is happening here. So when it loaded these DLLs, typically DLL injection goes like the binary is trying to load b.dll, but b.dll doesn't exist in the path or in the folder or somewhere that this binary is making a reference to. And then what you can do to inject your DLL is to choose offer this binary the DLL that is missing, and then it gets the DLL loaded into memory in runtime, and it might get as well the permissions. Most of the time, that's what happened, is that you will get the permissions, I mean the roles, access, and whatever is granted to this binary to the DLL, because the DLL is going to be loaded into the process itself as part of, right? All right. I'm sure you already knew this concept, but just refreshing the basics. All right, guys. So next, DLL, when you want to offer from the DLL a function that is going to be called by the binary itself, you need to export it. That's why on this case we have on this code we have extern C, DLL spec, DLL export, and we are exporting a function that is going to be called by the binary. How can we get to know the binaries and the exported and the imported, and what are the DLLs that are trying to call, or the ones that they call, and so on? So we can use something from sysinternals. It's called Prosec Monitor. You might hear about it, you might be using it, and you might know how to use it, but I'm going to show you anyway. So we can move on into, so this is where you get it. I already have it here. You uncompress it. Externals, and then you look for Procmon. It does need admin rights. So when you have it like that, and then let me uncomment this. Okay. So then you will have a Procmon like this. If you press Control L, you will get the filter, the filters. Yeah, or I think you can open it somewhere as well. Yeah, like filters here, filter. If you want, you can do where is it? Yeah, options, enable boot login, and then you can say generate profiling events. And you generate profiling events, a log with the profiling events for every 100 milliseconds, let's say, and then you press OK. And the next time your machine boots up, you can get the log of Procmon with all this log. So the next time you open again Procmon, and then you can see the processes that were running during boot time, and also get it not only in real time. So if you want to clear the screen, press Control X, and then you can clear it. If you want to pause it, you can pause it. You can auto scroll. You can, yeah, and of course the most important is the filters. So let's say let's use something that that you can use as well. Say calc, right? Calc.exe. So let's open the filter and just say process name is calc.exe. Of course, you have different conditions. Say add. Okay, and then it's gonna filter only calc.exe. When I open it, what is not? Maybe it's not calc.exe anymore. Let me check. Let's do something else. Process cmd.exe. Yes, there you go. Okay, so you open cmd.exe, and then you will see that now I only have cmd.exe here listed, and wherever is using cmd.exe, I will have it here. So with the results and the details, if you want to define this, for instance, if you want to know what's the username that is running it, then you can add it as a new column. And then from here, if you want to only show the name not found, choose as an example of you have a DLL and you want to, and it's not found and you want to replace it like the typical DLL injection style, then you can do that as well. And then you can say ends with DLL and is not found. So it's the result. You need to select it from here. It's gonna be the result here, and then you say name not found, and then the path, that is this one, ends with, this is the condition, DLL. So like that, I have these three. So now if I run it, it will show me cmd.txt. If it's missing something, it's gonna show it there. Okay. So it's not missing no DLLs, but it's missing something else like registry keys and so on. All right, so let's remove this one and remove that one. So now we understand a little bit, and I think we can just remove it. And then we can leave those. Okay. All right. So if we go back to this guy, then and this code, you can actually find it here on exploit pack. If you go to advanced DLL injection, you will find this code. Yeah, that you can compile, and I can explain you what it does, because now you know that you can inject into a process as a DLL. So if you want to keep access on a machine, you can use as an auto run technique, you can use a DLL, you can use Zondet, you can use the garbage collector. There are tons of ways of getting a DLL injected into a process. You can rename a DLL. You can do a trampoline function. You can replace a system32 DLL with yours, then load yours, then load. That's a really simple scenario, but works. So you can rename a DLL from system32, then put yours, then load yours, then load into your DLL the original DLL, then exit your DLL and leave the other one running. Or you can load your DLL and then move it to somewhere else. Yeah, you can do tons of things. Yeah, you can. Yeah, so basically there is a lot of things you can do with DLLs, and as of today, so 2022, most of the Windows processes and binaries, they do not check. They have not implemented a checksum check for DLLs. So basically, any process that runs or loads at, not any process, but like 99% of the processes, they will load DLLs and they will trust the DLL because it's on Windows, it's on a folder that a regular user shouldn't have access to, but you already have, because you already bounded that machine and you want to have you want to use DLL as a post exploitation technique to keep control of that machine. So yeah, so it works. All right, but this advanced DLL injection code, what's gonna help you with is to understand what is the process that you are injecting to. You can have the name of the process injected, and then you can do something if that process is injected. For instance, if you get an injection from calc.exe, then you can say, okay, then every time calc.exe trying to use the multiplication, then you replace it for division if you want to make the user crazy. If or if they are using the browser, then you can say, okay, but besides doing that, send the passwords to that the user just had typed, then send the passwords to this email address or something like that, because you have control of the process that the DLL is injected into. So, and with this code, what you can do is to get the process username, get the process name, of course, process to ID name. So you will get the process, you can get the process username, and then You can do whatever you want with this process. That's up to your imagination. So in this case, what's going to happen is it's going to drop on, say, Windows tasks or wherever you want it, a TXT file with the process ID. Is also going to drop the process name and injected as, so it's going to get the process username. All right, and besides that, it's going to drop in C Windows System 32 a new DLL called admin, and then this DLL is this is basically a base 64 code that is dropped there. Is the origin is this DLL, but in System 32 admin if you wanted to use it for something else. All right, so and why is it dropping it like this? Because if it can drop a DLL into System 32, this DLL is meant to be used as a vector of attack, like an injector. So to check if the injection was successful, because then you can run this in boot or with any amount of process, or you are trying to test more than one process or take previous escalations. That's the aim for. And if you get to write admin.dll in System 32, then it means that you either are system or you have services, right? Or or you are trusted installer, but for some reason you have access, you have write permissions is to System 32. So let me show you how it works. So basically you have the code here. What you're gonna do, you're gonna compile it, build, and here you can change it. You can add the code you wanted. You can replace it. You can export the DLLs that you the functions that you want. Oh, before moving into that, let me quickly show you how to find quickly with Jira. I'm not gonna show you with IDA because I know some of you guys doesn't have it. So I'm gonna well, new project. Then we need to create a project, test. I'm gonna show you with IDA. I think I already showed it in past trainings, but so let's look for a binary. CMD, can use that. And we add it here. Going to be trusted installer. So let's do it for binary insha. Let's get it like that. Okay. Then we open it. All right. It's taking some time. All right. Guys, if you have any question or something, something that is not clear, please say it out loud. Ah, finally. All right, so we open it. It's gonna pop up from the tool chest, the compiler. So we can say analyze. And then here, basically, what I'm gonna show you, maybe I can already show you here, is that we can go into the export functions type here in the symbol tree. So if we go into the imports, we can see all the imports that this binary ninja.dxe binary has. So it's loading all these DLLs. And if we go to exports, we can see all the function that is exporting. And inside of each one of those, so basically from kernel 32 is loading all these things, all these functions to this binary engine. So it's not loading the whole kernel 32, and it's not loading the whole Qt5 core, or maybe it does. That's a lot, but yeah, you can see exactly which function for example, from shell 32.dll is loading command line to arc w and sh get folder path a. So if you double click on this one, you will see exactly in binary ninja.exe, where is loading this, and this is the cross reference that it has, and it can show you on this call, and you can follow it up on the code here. But from here you can see what, so the exports that you will need to do in your DLL in the case that uh, is importing a DLL that you don't have, right? Or a function that you don't have and that you need to export on your DLL when you are trying to do the injection. All right, so let's stop this. And let me show you how it's done with this DLL here. All right, and of course, you don't need this. So this is in case you are doing it for another binary. All right, so we have it compiled there. We need to move it. Take it here, boom. Then we can copy it, put it into Windows task. I already have a few executions from a previous one, so I already have it there, test DLL. So what we're gonna do now, so if we run it, you can see here, if we go to tasks, so far we have nothing, but if we open something that that might, for instance, use .NET or something, then we have some execution, and our DLL was injected in this case into this process MMC, right? So it is injected into that process. Let's see. So this one, and if you want to check it, it's already, so basically what I have here is the DLL there, and I have the core profiler with the values that I said. Then I'm gonna restart the machine. You will see after I restart the machine that I got execution from that DLL. And of course you can, if you can make calls to your favorite shell code or anything from the DLL or a stager or anything. So if I go there, I'm still loading. Now if I start using, I take some time to load stuff. Open some stuff. Oh, for instance, Visual Studio will get injected. Yeah. This is an example. So we get injected as EA user, then process, blah, 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 and then the controller, PID 9952. And then let me show you, for instance, a privilege escalation. For that, yeah, this is what Windows exec. So what we can do, we can call from here, Windows exec, so the injection, and then we're gonna call this from here. Let's see if this works. All right. So I'm gonna replace the DLL with the new one. And now it should pop up a CMD shell besides making the injection and dropping the file with the properties that we set. So task, right, and copy. Oh, did I copy like the path? I think I did that. Okay, you go there like that. So we need to remove this one. We're gonna call it the new one test.dll, and then let's see if I do task scheduler. Yes. So you see that I'm getting a administrator. So basically, guys, this is a .NET profiler thing with the DLL injection that is getting me to escalate privileges from regular user to admin. So if I we have no files now. Okay. So if I open Visual Studio or anything that use .NET, you see I get a new file. Get this 3 times it has been called my DLL. See, I have this path, and then if you see here is choose a regular user. See, I'm not admin on this one, right? But you can see it here, check the last user. But if I open MMC or task scheduler, task scheduler, you see here I have escalated to admin. It says administrator, right? Just as if I was doing this, right? So that's a UAC bypass. So from the DLL, without doing anything, if I open task scheduler, boom, I get admin. All right, that's how you get admin. Just a simple way of getting admin on a Windows box. And then from after you get admin, you can get system. And after you get system, you can replace the DLL from System32 or from or become trusted installer and replace whatever trusted installer have access to, and then make a trampoline function or whatever you wanted. So the sky is the limit with your imagination, because you are starting coding whatever you wanted. But you can use this as a vector of attack to start looking at those. Well, this one I don't have permissions because it's, if we go here, I need to be an admin to look at these guys, because it has been created by an admin, right? So, actually, what I can show you what would happen if we replace, well, if you replace test DLL with something from System32, right? Then you will get system, of course, because it's gonna be called by something that calls system, or yeah, that's how it works. All right, guys, I think it's enough for today. I'm not gonna go, I don't want to go deeper into DLL injections. I think that's enough for you to start playing around. So what, what you can do is to, well, also you have the trust installer execution here that you can use. You can use the .NET profiler trick that I should show you, and then start playing with this advanced DLL injection to get execution of your red team agents. You can get execution in auto round with the BBS shell, and then every time the machine boots, you will get access to your shell. Unauthenticated and undetectable by IPs, and it works as of today. So have fun, and I hope you enjoyed this training, and well, see you next month on the next one. Thanks, guys. Have a good one. Bye.